Hello everybody, welcome to part 12 of the OpenThread 101 series, and in this video I will show you how to send a UDP packet using the OpenThread API. So we would continue with our OpenThread border router from the last video, and the border router here is basically running in the Docker mode. And what we will do in this video is send UDP packets using the OpenThread API. There is also a way to do this using the Zephyr Sockets API because Zephyr obviously supports OpenThread, and the Zephyr networking APIs then also has support for the OpenThread. So if you are using Zephyr sockets, which are more similar to normal sockets that you probably know, so we would do that in the next series where we would be talking about Zephyr. That series would be called Zephyr 101. But since this one is about OpenThread, so we will use the OpenThread API. And if you go to the documentation for the OpenThread API, you would see all these modules that are supported, including BLE, CoAP, some crypto, DNS stuff. Yeah, some of them I don't even know what these are for, but you have to just look at what these are and how to use them. So now we are interested in the UDP, so we go to the UDP part, and that's the reference for us. And there are several type depths, structures, and functions in this reference for the UDP. And yeah, what we are interested in is the functions. So we want to use the OT UDP send function. So that's what we would use. And here are the parameters for this. So we would also have to create and initialize these parameters to the proper value so that then this function would work. So let's get started. So we will start with the CLI command or the CLI application. So let's just create one. OpenThread CLI sample. This one is CLI 2. It's all right. It would, because there are probably already some CLI examples in that folder. So let's add our board in there. And so we would do nrf 52840. So this one, and let's build this. Okay, so the building has been completed, but still I want to make one more change here. So here, this is basically the CLI, and what I want to do is to enable network auto start so that we don't have to manually enable the networking information. So what we can do is there's a option for this, kconfig option for this. So we would do is config OpenThread and then manual start, and the default value for this is yes, and that's what currently has been using. So we would do a no for this one. That means that the network does not have to be started manually and it will start automatically. If you you can read the documentation here as well. But what this would do is it would basically then it will configure the network parameters from the using credentials stored in the persistent storage. So if there is an active data set that is stored in the persistent storage, then it will just use that to join or create the network, and or it will obtain it during the commissioning. So or pre-commissioning. Pre-commissioning is when we define all the information here, here or through some other way, but those network informations are in the persistent storage. We can do this from here as well. So if we do config OpenThread network name, blah blah blah, and then config OpenThread network key something, and then you can also specify the required PAN ID and network PAN IDs and things like that, so that it actually joins the network instead of creating its own network. But if you don't specify anything and it does not find anything, then it just initializes its data set with some values, predefined values, and so that's what we would do. So let's we will erase and flash our device. It will probably compile before, because we made this change. So let's wait for it so that the device is being programmed, and now it's building. Okay, so the device has been flashed. Let's connect with the serial terminal for this device. We see a star. That was from the banner, from the Zephyr banner. If we now check OT state, that's a leader. And if we check OT dataset active, there is some dataset, and the network name is OT Zephyr. There's a network key. You'd copy the network key because we want to join this network from the border router. So we go to the border router. There's already some network there, but we would search for existing networks. So this is 11 channel, and ABCD is the pin ID, and here this is pin ID and 11. So let's join this network. We would use the network key and paste the network key that we copied before. Join operation is successful, and now we have so our device has joined the network. Now currently our device is a child. We check again. Now it has become a router, and if we check here, this is a leader. So every router has the list of all other routers on the network. So if we go to the router table, now we have 2 devices as routers, and there are also neighbor table, which means which device are connected directly or are on the same or one hop distance from this device, or on the link distance. Yeah, so this is how you make this device join a network. This data where is it? Here is the device. So this data set is already in the device persistent storage now. So next time when you are flashing this device, we don't want to use the erase in flash. Since this is a default, it might work, but we would, if it's a default and we do erase in flash, maybe we would get the same dataset again. But just to be on the safe side, and we don't want to use the erase in flash. We don't want to erase this information. So I would close the device, and then what I would do is go to the source file. In the main file, we don't need a lot of this stuff. don't need the USB devices. I just remove this as well. And we need these two maybe, Zephyr kernel, maybe not, let's see. And then we remove all this information from the, we don't need the BLE, we don't need the low power stuff. We want to make it as simple as possible. Let's remove the logger as well. You would just use printf and remove this information as well. First of all, we should include Zephyr kernel and kernel.h. This should give us some function related to timer, and we would use that in our loop. So basically what we want is we want our program to send a UDP message every 5 seconds. So we would do is k seconds, and that would be 5. So this function would basically this loop would basically run every 5 seconds, and we want to do is to print k here, and that would be for now hello world. So we would print hello world every 5 seconds. So let's flash this. So the programming is complete now. So, and go to terminal and go to our device, and here you see that it's printing this every 5 seconds hello world. So that's our starting point. So what we would do is our message is basically this hello world string, and this is our yeah, what we want to send. And let's close this. What we need now is hash include OpenThread UDP.h, just like I showed you. And if you go into this UDP.h, there is UDP send datagram command. So this is what the function that we would use, UDP send datagram. So let's just paste it here. Just make some room down here as well, make some room up here as well, so that we have some room to work with. And this function is returning an OT error. So we would here we would initialize variables and structures. So here we would just initialize some variables that we need. So the first one is OT error, and that means that here, if this function would return an error, we would check f error. And now what we want to do is to check the return type. So there are these types that it can return. So we would do is, if error is on success, it is returning OT error none. So that means if it fails, if error OT error none, if this happens, that means there was an error. So the function was not called, the function execution was not successful. So we would send is failed to send UDP datagram. for now we would just use the print k instead of using a logger module. In actual programming, you would use, instead of this print k, you would use logger module, and then each message would have error or information or those levels, and then you can do a lot of different stuff with that as well. But that's a nicer way to, but for now just keep it as simple as possible. So this OT datagram function is taking as instance of OpenThread OT instance. So let's create this structure here, and this one is we get this from the Zephyr. So this is a pointer to an OpenThread instance. This basically allows us to control the OpenThread network, do different stuff with it, and all the methods, almost all the methods, need this structure or object. And so to get this, we have to include a header file, Zephyr net OpenThread. This is where it comes from. And then we do is OpenThread get default instance, and that's it. So this function is now, so here basically now we can pass it like this over here. It's already a pointer. Then the next one is OT message. So let's create that as well. And this we get from UDP. So it's OT UDP new message, and this is the function that returns us this structure or this object. And here the parameter, the first parameter is the OpenThread instance, so we pass it. And then there are some settings. We will use null here in the settings, and that's basically, we have those two parameters done. The third parameter is OT message info. If you go to the definition of these ones, this one is basically implemented outside. Here, this is just the definition of this, and we use this with different methods. This one is also implemented somewhere outside, and we don't want to their implementation detail, their internal details are kind of private for us. So we use these methods to get them and then interact with them. So basically these are just either return values or passed as parameters to different functions. This message info is something that is visible to us. If you go here, this is the structure, and what we need to set here is the destination address and the destination port. So let's get that. So what we need is basically we would do is OT message info, and then a message info is the name, and this is what we have. And then we want to make sure that the memory locations where this object is living does not contain some garbage value from before. So I guess in C++, you can probably ensure this. In C, maybe there's a way. That's just I've seen a lot of examples do this, so I would do this as well, just to be on the safe side. So we would pass the address to a message info, then we would write zeros there, and size of a message info. So this would ensure that the memory locations or the memory area of this structure would be 0. Then we would do a message info that peer port would be 222, yeah, and then a message info dot m peer address is something that we have to set, and this is an IPv6 address. You can't so this is an IPv6 address, so we have to our address that we have is a string, so we'd have to convert them. There is a method for it called OTIP6 address from string, and the first parameter is the IPv6 address. The second parameter is the message info. The second parameter is the address to the object where you want to store this, and the return value is the OT error, and if error, basically the same thing here. Failed to create OTIP6. This is put OTIP6 address, right? Failed to create OTIP6 address from string. And yeah, so this is how we make this structure. This address I will replace with the address IPv6 address of my computer. So let's do that later. So we have the address, we have the message info, we have, so here we pass the structure of this thing, and here we just want to add a print case statement that says message sent, and then \n, so that, and then every 5 seconds. And in this case, if everything is fine, maybe the program would not reach here, but it's just nice to have a consistent return, so we would just return error none. And this is how you would send the UDP packet to this target. Now my IPv6 is public, but I would use something which is also part of OpenThread called NAT64, so Network Address Translation 64. I don't want to write the code for doing that here, but what I would do is basically ping my IPv6 address in the OTCLI. So here what I would do is yeah, the hello words would keep printing. What I would do is OT ping, and then my IPv4 address, and in the pinging process it will give me the IP version 6 representation for my IP version 4 address, and we would use that address here. So let's do that. So first of all, I will copy my IPv6 address. Okay, so I have my IPv6 address copied, so let's ping it. So we would do is OT ping and then this, and basically it pinged the address, and it basically used this as a destination. So this is what my address should look like here, and basically from the OpenThread perspective, we are sending a UDP packet into this device. Then the border router translates it into an IP version 4 packet and send it to my computer. So that's our firmware. Let's flash it, and basically every 5 seconds it will send a message. So let's flash it. Let's see. Okay, so everything should be fine. Okay, so the device has been flashed and it is basically doing the message send OT state and OT dataset active, and OT debug just to see if it's so it still has the 2 routers, so it's part of our OpenThread border router. It's part of the same network with the border router, and it is doing this message send every 5 seconds. Now let's see if we can actually receive this message. There are multiple ways to do this. We can use Wireshark as well, but let's just use a simple Python script. So here I would just write UDP server.py, and for this I would enable the copilot so that it just helps me quickly. So you would say UDP server to listen to UDP packets on port 222. Okay, I guess that's enough. Let's just choose this definition main, and yes, it is basically no, this is not what we want. So it gives us the if name equal to main, and then we call this function. Okay, and I guess this is good enough. We have to update this address 0.0.0.0 so that it's listening to all addresses, and then it will send the print the message that it received. So let's see, maybe this should work. I would open a new terminal window, CLI. This one is CLI 2, and then source, and we have Python 3 UDP server.py. Okay, so address already in use. Somewhere it's being used, so I guess it's here, probably from the last run. So I would just do it again. So it's now listening, and it's received 0 bytes now. So it's sending a package, but we forgot something here. So what we forgot is we are creating a message, but we are not adding our payload here. So what we need to do is there is another method for this. It's called OT message append, and then let's disable this guy. It just makes everything worse. So we have OT message append, and then we have the a message, and then we have the message, and then we have the length. So the length is I guess it's string str length, and then we have the message, and we do it here, and if it's this one also, I guess returns OT error. Yeah, so we would do is error equal to this, and then we copy this error checking from here so that if something goes wrong we get an appropriate message on the UART. Just fix this here as well. Add a dot and add a end line, add an end line, maybe a dot and an end line here as well. And here we would say is failed to append our message to OT message. And now let's increase this interval to 10 seconds. And because 5 seconds is probably a bit too often, so let's flash it now. Okay, so it's getting flashed and it is sending a message. Now we can also see that the message here is coming as a hello world. So basically, yeah, it's from here it's sent, I guess, 3. Here maybe some buffering going on, or because of the print statements or whatever. But we are receiving the message here at my PC, and you can see the source is coming from 172.17.0.2, which if you know Dockers is basically address that is used by Docker a lot. And since our border router is running inside a Docker, then it's sending it is giving us that message from our device. That's why the source here is this. I'm not sure. Probably this is the address of the border router, uh, the interface which is facing towards us. But here you can see that you can basically send a message from the OpenThread network to another network. And yeah, there is one additional thing, which is how would you use if you don't want, like this year I did a cheating, so I didn't want it to show my IP version 6 address, so I'm using this address. But you can also, in the code, you can extract this IP version 6 equivalent from IP version 4, and there's it's called NAT64. Yes, here NAT64. So here you have the module that you can use to translate an address, IP version 6 address, to IP version 6. Yeah, but I think for this video, this is enough for now. And if you have interest, then tell me and I will add that translation code as well. And this is it for now. Maybe in the next video we will start with the Zephyr 101 series, or maybe there are probably a few videos in this series as well. So let's see how the future goes. And yeah, thank you very much for watching, and see you again. Bye.